If just before you went into an exam, I said to you, look, by the way, I know 15% of the questions, you'd think it was cheating. But the truth is, we do know that, because we know that at least 15% of the marks will be on RPAs. So across your science GCSE, 15% at least will be on RPAs. They're required practical activities, meaning they're experiments you've done in class that you'll be asked about in an exam. And there are at least 7, well, there are 7 in biology, and there are more in chemistry and physics, and they have certain things in common. There are certain words you just need to know. Now, in the interest of not making this video a million hours long and actually, people being willing to watch it, I'm going to try and make it quite speedy and to the point. So you might need at times to pause the screen maybe to read something. So an experiment is just where you change one thing to see the effect it has on something else. And anything you're changing, measuring, or controlling is known as a variable. And there are 3 kinds. An independent variable, that's what you change so you can see what effect it has. The dependent variable is what you measure so you can see, well, what actually was the effect. And the control variable is anything that you keep the same. So you can be sure of whatever effect you see, you can be sure that it was caused by the thing you changed and not something else. So here's an example. Let's say I'm interested in that question on the board. Well, the independent variable, what I change, will be the height of the ball. The dependent variable, what I'm measuring, is the height of the bounce. And the control variable is keeping all those things the same that might otherwise impact the height of the bounce. For example, I want to use the same ball. If I drop a bowling ball from 10 centimeters and then I drop a rubber ball from 20 centimeters onto a trampoline and it bounces higher, I can't be sure if that was the trampoline, the ball, or the height that had the effect. So I want to keep everything the same apart from the independent variable. Let's just see if we could match these up. So here's another question again on the screen. The independent variable. So at the bottom I've got volume of water, type of plant, gain in height. So the volume of water is what I'm changing, so that's the independent variable. The type of plant and the soil, etc., they're the things I need to keep the same, so they're control variables. And dependent variable is the gain in height of the plant, that's what I'm measuring. So I've got my results, and here they are for some other experiment, but that doesn't actually tell me anything because there were no units on that. Here, time, 20, 40, 60, 80, could be days, could be years, could be seconds, but now I know because I've got the units that it is seconds. So you should always, always, always include your units, please. So here's another one. So now I've got a graph, but once again, there are no units, and worse than that, on the y-axis, I don't even have a label. I've got no idea what that's telling me. 10, 20, 30, 40, could be anything. So once again, you have to make sure that you include units, because I don't know what it is, but not just units, labels as well. So you've done your experiment and you've got your results, and you have a question that says, were there any anomalies? And an anomaly is just something that doesn't fit in with the natural range. So it doesn't fit in with the pattern. So here's an example of a table, and as I look across, I've done 3 repeats at each distance, and if I have a look at the 30 centimeters distance, 15, 29, 16, that 29 is outside the natural range, so there's been an error there, something's gone wrong, and I've got an anomaly. Or on a graph, the anomaly is going to stick out like a sore thumb, and for example, it's that one there ringed in blue. So that's all anomaly means, it's something that doesn't fit in. You might have done your experiment, got your results, and you're asked, is it accurate? That's, is it close to the true value, the actual answer, or is it precise? As in, is there much spread around your results? So I'll explain what I mean. Let's say the true answer is the bullseye. That's the actual value. And here you can see I've got 4 answers all close to the bullseye. So that's not only accurate, it's close to the true value. It's very precise because there's not a lot of spread among my different results. This one here is not very accurate. It is, however, quite precise because they're all close to one another. The third one here is pretty accurate. They're all quite close to the true value, but they're not close to one another. There's quite a range, so it's not very precise. And that fourth one is neither accurate nor precise. So for example, the one on the far left, if the result of, let's say the experiment is how tall am I, and the answer was 100 centimeters, if my results came out 99, 100, 101, 98, and 100, that's accurate and precise. It's close to the true answer and to one another. The one on the far right, for example, might be if my results were 50 centimeters, 150, 75, and 6. It's not close to the true answer or to one another, so it's neither accurate nor precise. And almost there are repeatable and reproducible. So something is repeatable if the same person repeats the same method, same equipment, and gets the same results. That's a repeatable experiment. A reproducible experiment is if it's repeated by a different person and you get the same results, or it's the same person but they use a slightly different method or equipment and they still get the same results. I think of it a bit like this. I used to be able to put the TV on at any point and I'd see an episode of Friends, and they were always showing repeats. And in a repeat, it's the same people, the same cast, the same script, the same outcome, just like a repeatable experiment. Same people doing the same thing, same results. So that's a repeat of a TV show, and that's a repeatable experiment. Reproducible, I don't know if you've seen this show, but this is The Office. On the left is the English one, and on the right is the American one. So now I've got different people playing the same character and the same script to the same result. And that's like a reproducible experiment. It's different people following the same method for the same results. So lastly, just to say really, bullet pointer method if you have an opportunity. It's always worth guessing. You won't lose any marks, but if you don't answer anything, you definitely won't gain any. Don't be put off if you see a graph or a table, and we're going to make a whole bunch of RPA videos. So watch them, and then if you're confused about some of the words we mentioned, independent variable say, come back and watch this video. Hopefully it's been useful.